Okay, let's dive in. So try to picture this. Imagine cities, right, where buildings just float.
Mm.
No massive columns, no deep foundations, just suspended
Eh.
in the air. Or maybe vehicles that glide silently, no engines, no fuel, just moving through a city where gravity itself feels different.
It sounds like pure science fiction, doesn't it?
It really does.
Yeah.
But this is the ambitious vision behind something called Spacetime Anchorage, and that's what we're unpacking today.
Yeah, this is a concept that suggests we could redefine our whole interaction with reality, really.
We're not talking about simple anti-gravity like you see in old movies, or just basic levitation. This is supposed to be, well, a much deeper manipulation of space-time itself.
Exactly. It taps into these subtle, perhaps unseen dimensions that advanced physics theorizes. The idea is to generate a very precise, very localized ripple, a disturbance in the universe's own gravitational field.
So our mission here is to give you, the listener, a kind of shortcut to help you get your head around the core ideas pretty quickly.
Right. We'll look at how it's supposed to work fundamentally.
And then we'll explore the two big applications that keep coming up. This idea of aerial architecture and this other one, silent, effortless propulsion.
Yeah, the static and the dynamic uses.
Okay, so the big question first. How could you possibly even begin to control gravity like that? What's the mechanism?
Well, the core idea introduces something called a space-time anchor.
An anchor,
Yeah.
but not like a ship's anchor, I assume.
No, not physical at all. A space-time anchor is basically a localized region of space. Inside this region, a special device, they call it an Isotropic Gravitic Field Projector, or IGFP for short.
IGFP. Got it.
This IGFP actively and very precisely counters gravity's pull.
Okay, counters gravity.
Yeah.
But how? Without rockets or, some massive energy beam pushing up, it sounds, well, magical.
Well, it definitely pushes the boundaries. It relies on some pretty cutting edge and admittedly theoretical physics. We're talking about something called hyperdimensional resonance.
Hyperdimensional resonance. Okay, break that down a bit.
So imagine the universe isn't just the three spatial dimensions plus time that we experience directly.
Right.
Advanced theories, things like M theory, for instance, they propose there might be other subtle, folded up dimensions, unseen ones.
Okay.
The IGFP is theorized to sort of resonate, interact with these deeper dimensions. And by doing that, it subtly tweaks or changes the gravitational constant just in that specific localized area.
She's saying it's like changing the rules of physics, but only inside a small bubble.
That's a good way to put it. Precisely. It effectively carves out what you could call a gravitational null zone.
A null zone.
Think of it like blowing a perfect soap bubble, but instead of soap, it's a bubble of weightlessness. Inside, the normal pull of Earth's gravity is just completely canceled out, negated.
Wow, so anything inside that bubble would just float, like being in deep space.
Pretty much, yeah. Completely unburdened by its own mass, effectively. And that really challenges our basic ideas about stability, about construction, about how things need to be supported.
It really does. I mean, it turns centuries of engineering principles completely on their head.
Yeah.
So if we can create these null zones, what does that actually look like in a city? I'm trying to picture.
Oh, it's transformative, really. Think about, say, streetlights floating midair. Just the light source glowing, suspended without any ugly poles.
Huh?
Or picture huge skyscrapers where the upper floors aren't just scraping the sky. They're literally tethered to these invisible anchors. They might seem to just blossom out of the air itself.
So the whole idea of needing massive foundations just goes away. But surely there are challenges. What about energy costs? Is maintaining this weightlessness practical for, like, a huge building?
That's a key question, absolutely. The theory suggests that once you establish the null zone, the energy needed to maintain it is actually much less than the energy needed to create it initially.
Ah, okay, like inflating a balloon versus just keeping it inflated.
Sort of, yeah. And the huge advantage is removing the need for those colossal deep foundations. Think about the materials, the concrete, the excavation.
The environmental impact.
Exactly. Huge concrete pours digging deep into the earth. A lot of that could become unnecessary. We could potentially build cities with a much smaller material footprint. It frees up ground space, allows for designs we can't even really conceive of now.
So stability comes from just being weightless. What about wind, though? Or other forces?
Right. They'd still need some internal structure, minimal support really, just to counteract external forces like wind shear. But the primary load, the building's own massive weight, is handled by the anchor. It's a complete rethink of urban design.
Okay, so if you can anchor buildings in the air,
Yeah.
the next logical step seems to be movement, right?
Yeah.
Could you use the same principle to, I don't know, make things move, like vehicles?
Absolutely. And that's exactly where the second major application comes in.
Yeah.
Gravitational displacement drives, GDDs.
DDDs.
These are pitched as the engine for the next generation of transport.
So how did that work? Is it like a portable anchor?
Not quite anchoring, more like manipulating gravity on the fly. It's about creating a silent revolution in how things move. Forget noisy engines, burning fuel, forget even air friction.
No friction.
A GDD-equipped vehicle moves by dynamically, constantly manipulating the gravitational field around itself. It doesn't push against the air or the ground.
So wait, no exhaust, no sonic boom potential even at high speed, no wake? How does it generate thrust if it's not pushing against anything?
It uses arrays of emitters. They're called Directional Gravitic Field Modulators, or DGFMs.
DGFMs, another acronym.
Yes. These DGFMs are constantly creating and shifting tiny but very powerful gravitational, let's call them wells or hills around the vehicle.
Gravitational hills and wells.
Yeah, imagine the DGFMs are like constantly sculpting the space-time fabric right around the vehicle. They create subtle slopes, inclines or declines in the local gravitational field.
Okay, so the vehicle isn't being pushed. It's constantly sort of falling downhill, or maybe being pushed uphill by gravity it creates itself.
That's an excellent way to think about it. It doesn't push against anything external. It simply falls into its own self-generated gravitational landscape, or perhaps it's repelled away from a gravitational hill it creates behind it.
And that's why it's silent and smooth.
Exactly. An eerily silent, incredibly smooth ride. That's the description often used. And think about the benefits. You could accelerate incredibly quickly, but feel no G-forces.
No G-forces? Really?
Because you're essentially falling with your local gravity field. You could change direction almost instantaneously on a dime with no jolt. The DGFMs are literally sculpting space-time, creating an invisible pathway for the vehicle.
That's mind-bending. So what does this really mean for, for us, for the listener's own experience of travel, beyond just quiet and smooth?
Well, think about your daily commute. Imagine it being effortless, silent. Think about long-distance travel across continents, maybe being as smooth as just thinking about going there. Or even space exploration. Suddenly you're not as limited by carrying massive amounts of fuel or reaction mass. Travel could become truly efficient, almost part of the environment itself, rather than a noisy disturbance in it.
Okay, so let's just quickly recap this. We've got Spacetime Anchorage. It uses these theoretical IGFPs and hyperdimensional resonance to create null zones for floating architecture.
Right, aerial architecture.
And then it uses GDDs and DGFMs to manipulate gravity for propulsion. Silent, smooth, efficient movement. It definitely feels like it leaps way beyond typical science fiction tropes.
It really does. It represents a truly ambitious conceptual leap, trying to control the fundamental forces that shape our universe. If it were ever realized...
If, yeah, big if.
Big if, absolutely. But if realized, it wouldn't just reshape cities and travel. It would fundamentally change our whole relationship with the physical world.
It really makes you wonder, doesn't it? If humanity could genuinely gain control over gravity, how would that change everything? Not just our buildings and cars, but our understanding of physics, maybe even our place in the cosmos.
It's a profound question. How would controlling such a fundamental force alter our trajectory?
Definitely something to think about. A provocative thought to leave you with until our next deep dive.